And before we talk about drawing UMO class diagrams, there's one thing I want us to discuss, which is the kind of relationships between classes and how you figure out which relationship this is, right? So we basically have three types of relationships. We've got composition, we've got aggregation, and we've got association. You want to know, when is it composition, when is it aggregation, and when is it association? How do you know? And that is a very popular question with most of you guys. So let's dive straight into it. So composition means that the child cannot exist without the parent. So in other words, your class, in this case body, is composed of another item or another object, in this case which is called a leg, right? So body is composed of a leg, car is composed of a tire, right? So in terms of composition and aggregation, there's one thing in common. Your classes will have the item as part of the class. In other words, it contains it, or in other words, it is composed of, right? So you see that under private, you've got a leg, under private, you've got a tie. This is something that is common between composition and aggregation. Now, the main difference becomes the kind of variable that you're dealing with. And get me right, when it's a pointer, you are most likely going to go with composition, because what happens with composition, we are saying that whenever your class is destroyed, it's going to destroy its child. So you see that I've included a destructor here, which deletes this leg, which means every time an instance of a body is deleted, it deletes an instance of all the legs that it contains, right? Therefore, we are saying that this child cannot exist without its parent, because every time we delete the parent, it deletes the child. So this is a composition relationship, right? So you can draw this one now, saying body here, and then that, then you put your leg here, and then composition, your diamond here is actually solid. That's how you do a composition relationship. Now, I'm not saying that every time you see a pointer, then it's composition, but I'm saying, since in most cases, we have a pointer in a class, we always delete the pointer. It's very likely that every time you see a pointer within a class, that relationship between the class and the child is a composition relationship. But it's possible for a class to have a pointer, but the relationship is not composition, because the class is not responsible for deleting that object. Okay, so every time I see a pointer, the first thing that crosses my mind is this is a composition relationship, but just be careful, because there are cases where it might not be composition, right? But that's basically what is a composition relationship. Now let's talk about aggregation. Aggregation means your class contains an object, but it's not responsible for controlling the lifetime of that object. In this case, it's not a pointer. So if it's not a pointer, it's not up to this class to delete this object. Your compiler will control that, or some other object sitting somewhere. So in this case, we say it's an aggregation relationship. So we are saying, yes, our car has a tire, but a tire can exist without a car. It can exist outside this instance of a car, which is not the case here, because this leg cannot exist outside this instance. The moment this instance is gone, then the leg is gone. Just like you don't see legs moving around in shopping malls, because they cannot exist without a body. Composition, all right. So the same thing goes here with aggregation. So you can buy a tire, right, without the car. So it simply means that your child can exist without the parent, or in other words, this class car is not responsible for controlling the lifetime of this tire. So you draw this one by going, I've got a car, and sorry, let me draw this quite nicely. You've got a car, then you put your diamond here, then you've got your tire sitting here. This is an aggregation relationship. So the difference being, this one is solid, this one is empty. Okay. Then association is different in the sense that your class does not contain the object, but it uses it somewhere within its functions or somewhere within the class. So there's no direct, the class does not directly contain, or it's not directly composed of that object, but somewhere it uses it. Like in this case, we can see that if we are going to build this successfully, we've got to hash include this class called candy, right? Otherwise this won't compile, isn't it? Which means we need to use this class inside person. So in other words, we use it, we need it, it has to be there, right? So that's association for you. It means it's not contained, but it's being used. That's association. So the moment you see a class within the functions, or maybe it's being returned, or it's part of the arguments, something like that, then you know it's association. And with association, you are saying, therefore, a person uses candy. So the basic way of explaining this is, would say body owns leg, car has a tire, and person uses candy. That's more like how you describe these relationships. Composition, you are saying the class owns it because it cannot exist outside that class. With aggregation, we are simply saying it has. Why? Because, well, that thing can still exist without the car. And with association, we are saying it uses it. It's part of the class. It's used by one of the functions of the class. So that's it about association.